Good morning students. Today we will discuss about effective mass of electron. Now what is meant by effective mass of electron? So see here, when the electron is moving in periodic potential. So when the electron is moving in periodic potential, according to band theory, electron move in periodic potential. So for this electron, if we give electric field or magnetic field, if this electron which is moving in periodic potential is placed in electric field or magnetic field, so what happens? It gets accelerated, means its velocity increases. So the mass associated by the electron at this time is called as effective mass. So what is effective mass? When an electron in the periodic potential is accelerated by electric field or magnetic field, then mass of electron is called as effective mass. Now the force associated with the electron, so the force with which this electron is accelerated when electric field or magnetic field is applied, that force is given as F is equal to m star A. We know F is equal to ma. So here we write it as F is equal to m star A. Here m star is called as effective mass. Here m star is called as effective mass of electron. Okay. Now according to quantum mechanics, so when electron is moving electron always exhibits wave nature. So moving electron always exhibits wave nature. So what happens? This electron, here electron particle is moving in a wave packet. In quantum mechanics, the particle electron will be moving in a wave packet. So the velocity of the electron in a wave packet, we call it as wave velocity or group velocity. The velocity possessed by the electron in a wave packet, we call it as wave velocity or group velocity. Okay. Now group velocity is given as Vg is equal to d omega by dk. So I can write Vg as Vg is equal to, so see here, d omega by dk. D by dk, omega means angular frequency. Omega is equal to 2 pi mu. Its formula is 2 pi mu. So d 2 pi mu by dk. So Vg is equal to, I can write it as d by dk of 2 pi nu frequency. So what is omega here? Omega is angular frequency. Nu is linear frequency. Okay. Now 2 pi is constant. Bring outside. So I can write it as Vg is equal to 2 pi d nu by dk. So implies Vg is equal to 2 pi d by dk of, what is the energy of photon? E is equal to h nu. So from this nu is E by h. So I can write, instead of nu, I can write E by h. So we can write group velocity as Vg is equal to 2 pi into, here 1 by h is constant. So bring outside. So 2 pi by h d by dk. So this is the expression we got. Now we can write group velocity Vg is equal to, what is 2 pi by h? We know reduced Planck's constant h cross is equal to h by 2 pi. Then here we are having 2 pi by h. We can write this one as 1 by h cross d by dk. So this is the expression for group velocity. I got expression for group velocity. This is equation number 2 and this is equation number 1. Okay, this is the group velocity. Now I got velocity. Here I have in the expression F is equal to m star A. I have acceleration. A is acceleration. I got here group velocity. So I can find acceleration. Now acceleration A is equal to dvg by dt. Rate of change of velocity is acceleration. So A is equal to A is equal to d by dt of what is Vg? 1 by h cross dE by dk. This is from equation 2, above equation. From this equation I can write acceleration A is equal to d by dt of 1 by h cross dE by dk. So A is equal to 1 by h cross d square E by dk into dt. Okay. So implies I can write acceleration A is equal to 1 by h cross. I can write this as dE by, see here I can write it as d square E by dk square dk by dt. Can I write like this? So see here dk. I am multiplying with dk and I am dividing with dk. This is equation number 3. So this is the acceleration. Now we know momentum. We know momentum P is equal to h cross k. Momentum P is equal to h cross k. Last class I told you h cross means h by 2 pi. K means wave number 2 pi by lambda. So 2 pi get cancelled. We are left with h by lambda. H by lambda is nothing but momentum from de Broglie's wavelength. See here de Broglie's wavelength lambda is equal to h by p. So P is equal to h by lambda. So I can write it as P is equal to h cross k. Now differentiate. So differentiate above equation with respect to t. Now differentiate this equation with respect to t. We will get it as dp by dt is equal to h cross dk by dt. So dp by dt is equal to h cross dk by dt. What is dp by dt? Rate of change of momentum is nothing but force. Newton's second law. Force is equal to h cross dk by dt. So from this I can write dk by dt as dk by dt is equal to f by h cross. Okay. This I can write it as f dk by dt is equal to, see here, dk by dt I got it as f by h cross. So I'll substitute in this. This is equation number 4. So substitute 4 in 3. Now substitute 4 in 3. We get it as acceleration A is equal to, what is there? A is equal to 1 by h cross d square E by dk square. This is f by h cross. So 1 by h cross d square E by dk square into f by h cross. So I can write it as acceleration A is equal to 1 by h cross square d square E by dk square into f. So implies I can write it as f is equal to, if I take this all terms to this side, I'll get, see here, this is in denominator. If I take this side, it becomes numerator. H cross square d square E by numerator term denominator. This E by dk square into A. So this is the expression I got. F is equal to h cross square divided by d square E by dk square into A. This is equation number 5. So what is equation 1? What is equation 1? F is equal to m star A. What is equation 5? F is equal to h cross square by d square E by dk square into A. So comparing 1 and 5. So if I compare 1 and 5, I'll get effective mass as m star is equal to, so effective mass is equal to h cross square divided by d square E by, so see here, so we can write it as h cross square divided by d square E by dk square. So this is the expression for effective mass of electron. So this is the effective mass of electron. Okay, m star is equal to h cross square by d square E by dk square. Now we'll see how effective mass varies with respect to wave velocity. So the variation of effective mass, the variation of effective mass with respect to wave velocity. Wave velocity means a wave velocity or wave with respect to wave vector k. Now we will see the variation of effective mass m star with respect to wave vector k. Okay. Now see here. So this is m star, effective mass. This is wave vector k. Now the first Brillouin zone, the zone extended from pi by a to minus pi by a to pi by a is called as first Brillouin zone. So the variation of effective mass with respect to k is shown in the figure. So this is the conduction band. Now the variation is like this. So this is represented as k naught minus k naught, and this is represented as k naught. Okay, now we'll study the graph. Okay, see here at k is equal to 0. At k is equal to 0 means at this point here effective mass is equal to mass of electron. So here effective mass is equal to mass of electron. Both effective mass and mass of electron are the same. Next, as k increases, so see here, as k increases, what happens to effective mass? Effective mass also increases. So as k increases, as shown in figure, effective mass also increases up to k naught. So it increases up to k naught. K naught is called as inflection point. It is called as inflection point. Inflection point. Okay. So below k naught it is increasing. So next above, beyond k naught. So when it is beyond k naught, what happens is here below k naught, what happens? It is reaching its maximum value. Okay. After point of inflection, as k increases, what happens? Here m star beyond k naught, as k increases, effective mass decreases. See here it is decreasing. After becoming maximum, as k increases, it is decreasing. Okay. So after the point of inflection, it is decreasing. Next, so see here, now at the top of the conduction band, means it here beyond k naught, as k increases, effective mass decreases and takes negative value, and it takes negative value. So which is shown in the figure, it takes negative value. So here at the top of the conduction band, means at the bottom of the conduction band, if I see bottom of the conduction band, effective mass is taking positive value. At the top of the conduction band, means as I am reaching top of the conduction band, it is shifting towards negative. So m star is taking negative value. Okay. So effective mass can be both positive and negative. It can take both the positive value and negative value. So this is the variation of effective mass with respect to wave vector. So see here what we have discussed. The effective mass, At K is equal to 0, effective mass is equal to mass of electron. As K increases, effective mass also increases, but up to K naught. After K naught, it decreases and shifts towards negative side. This K naught is called as point of inflection. Next, at bottom of the conduction band, effective mass is positive. When I am reaching the top, it is shifting towards negative. So at the bottom of the conduction band it is positive and at the top of the conduction band it is negative. Means effective mass can take both positive and negative values. Okay. So this is about effective mass. Thank you.